Now let us see a case of differential equations which is reducible to the linear form. Now one of these is a very famous equation called as Bernoulli's equation, and it is given by the form dy by dx plus py equal to q into y raised to n, where p and q are once again either the constants or functions of x only. So if we just compare with the previous form that we saw, which was the linear differential equations, the basic form, there the term y was not present. Okay, so now here it is present. So the procedure to solve this type of equation is, first we divide both sides by y raised to n, that is the term appearing on right hand side as we saw. After that we substitute 1 upon y raised to n minus 1 with v, which is nothing but a new variable, so it's a substitution, and on doing this we get a linear form, that is a linear differential equation, and then we solve the linear differential equation by the already known procedure, that is to find the integrating factor and then write the general solution. So the idea is to divide by y raised to n and then use the substitution. Right? Now let's solve one question of this type. Here we are given dy by dx plus y equal to x into y square. Right? So here we see that y square is analogous to that y raised to n, and x is nothing but the function of x, which is the q. Right? So therefore, as per the procedure we saw, we have to divide both sides by y square. So therefore we get 1 upon y square dy by dx plus y divided by y square will give us 1 upon y, and on our RHS we have x. Now here we have to substitute 1 upon y with v. Therefore on differentiating with respect to x we get minus 1 upon y square dy by dx equal to dv by dx. Correct? So therefore on putting in the original equation that we got, we get first term as minus dv by dx on substitution, plus 1 upon y is v, what we substituted, and x remains as it is. So therefore just taking the terms on the other sides, we have dv by dx minus v is equal to minus x. Right? So this is a linear equation. If you observe, this is a linear differential equation, and if you compare it with dv by dx plus pv equal to q, so in that case p becomes equal to minus 1 and q becomes equal to minus x. Right? So therefore first we will have to find out the integrating factor. Now integrating factor is given by e raised to integral of p dx, so that further equals e raised to integral p is minus 1, so that gives us e raised to minus x as the integrating factor. Now we know that the general solution is given by, now here we normally write y, but now since it's not y but it is v, so we have to write it as v into integrating factor is equal to integral of q into integrating factor integrated with respect to x plus c. So therefore we have v into e raised to minus x is equal to integral of q is minus 1 into integrating factor is e raised to minus x dx plus c. Right? So therefore we have v e raised to minus x is equal to, now if we put minus 1 outside, we take minus 1 outside, then integral of e raised to minus x is nothing but e raised to minus x upon minus 1, correct, plus c. So therefore ultimately we get v e raised to minus x is equal to e raised to minus x plus c. Therefore, let us multiply throughout by e raised to x, so that we will get v is equal to 1 plus c e raised to x, correct? So finally, by replacing v with 1 upon y, we have 1 upon y equal to 1 plus c e raised to x, or we can write 1 is equal to y plus c e raised to x times y. So you can call this as the general